Howdy, this is a SolidWorks motion study analysis of my bench assembly for homework 5. Here's a 360 view of my bench, including the main frame, anchoring plates, and anchoring bolts used. Here you can see the 1/2 inch 20 hex bolts that are used to secure the assembly into the ground. There are a total of 6 bolts used to accomplish this. Next, you can see the 3 anchoring plates being exploded from the model. These plates are 8 inches by 7 inches and are 0.25 inches thick. They are welded to the bench legs using a 0.25 inch weld bead. These plates are made of 5052 H32 aluminum. Lastly, we have the main bench frame that uses 4 by 3 by 0.25 inch tubes for the framing and seat struts. These parts are also made of aluminum 5052-H32. This material was selected based on its high strength, good corrosion resistance, very good weldability, and long lifetime in outdoor environments. These parts are likely to be manufactured using an extrusion process and then hot or cold work to meet specific material properties. Material selection was also kept to constant to minimize high cost of low volume parts. Here you can see a zoom in up close view of the anchoring plates. As you can see, they are welded to the legs as previously mentioned. Here's an up-close view of the gussets that were also added to the bench frame and legs. They were added to the assembly to increase rigidity of the frame. They are to be welded also using a 0.25 inch weld bead. Lastly, there were 1 inch gaps that were placed in between each seating strut, and end caps were also added to the tubes to minimize collection of water and debris on the assembly. Maximum deflection calculations were made based on a 3 support system and concluded that the beam would only deflect 0.101 inches with a 1,000-pound distributed load. Lastly, the assembly's overall dimensions were 75.5 by 40.37 by 22 inches, and the final mass of the assembly was 256.83 pounds.